Hello and welcome to this lecture. My name is Chibuzor Marcel, and today I'm going to be lecturing on lunar eclipses, the science, beauty, and the mystery of the blood moon. Probably heard about the blood moon before, so we're going to be exploring the topic today. So, as part of the table of content of what I'm going to be saying today, I will give an introduction to the lunar eclipse and what makes the moon shine at night. I'm going to emphasize on that before I move on to the other parts. I'll give a historical significance of the lunar eclipses, and I'll also talk about lunar eclipses and their role in advancing science. Talk about the geometry of lunar eclipse and types of lunar eclipses that we have, and then I'll give an overview of the forthcoming lunar eclipse that we are expecting on August 27th to 28th. We're expecting a partial lunar eclipse. Okay, let me just be specific with that. Partial lunar eclipse. Then after that, I'll talk about why does the moon turn red? That's very important. Why does it turn red? Why not dark? Why not disappear? I'll talk about that. Okay. Then I'll talk about how to observe the lunar eclipse. So maybe some protections if there's any need for protections during the observation. We're going to learn about that. So, by the way, this lecture is sponsored by the Free Astro Science. You can check the website. They are the official sponsor of this lecture. So, introduction. What is a lunar eclipse? A lunar eclipse occurs when the Earth moves between the sun and the moon. When Earth is standing between the sun and the moon. Remember, for solar eclipse, we have the moon standing between the sun and Earth. So for lunar eclipse, we have Earth sitting or standing between the Earth, sorry, between the sun and the moon. So when the Earth sits between, because the radiation is coming from the sun, is going to develop a shadow which will be cast on the moon. Remember, it is the shadow that is the factor there. So when the moon, when the Earth is at its center, it casts its shadow on the moon, and that shadow that you're seeing here is what we call or refer to as lunar eclipse. Now, I want to do a recap of why the moon shines at night because a lot of people do not understand the dynamics. Okay, why the moon? Because a lot of people think that Earth is the universe. Because I'm talking to an audience of amateurs and experts and so on and so forth. So for most people, they think that Earth is the universe and the moon is inside the Earth. No. Okay, here is the sun. Here is Earth. You can see the day. The side facing the sun is the day, while the side facing out is the night. And here is the moon. Okay, so the sun emits light. You can see the parallel light in all directions. And because the moon is there, it hits the moon's surface and the light is reflected. And those at the night time, we see the moon as either the full moon or quarter moon or crescent moon, different kinds of moon phases. Okay, so this is what we see. So that's exactly what happens. So it means it is so. Look at this moon here. It means that it is reflecting. It is reflecting the sun's light. It is reflecting the sun's light. So it is not inside Earth. That's my emphasis here. It is not inside Earth. It is outside. It is orbiting Earth outside space, but it's close by. So it reflects the sunlight and we see the moon. Okay? So, and it's white. We're always seeing it as white. So look at that. We have always known that the moon is always like this during full moons and so on. So, but we rarely ever see the moon looking like this, looking pure red or copper color. So, what is going on here? What is going on? Okay, so why are we not conversant with this type? Okay, or maybe imagine, now we have, modern science. We always have ways to explain this and, to remove fear from people. But imagine that you were among the ancient people. And, Asian people are used to seeing this kind of moon at night, and the kids come out, they tell moon stories, they enjoy it because during full moon at night, in a village where there's no electricity, people can see and people can do some other things at night before they go to sleep. But all of a sudden, the moon turns like this at night, it becomes a very big problem, becomes a very big problem for the people of the ancient world because they can't explain that. It's rare, okay? It's rare. So that will bring me to the historical significance of the lunar eclipses. So, starting from the ancient Assyria in the 7th century before Common Era. So here is the Assyrian Empire there. Okay, lunar eclipses were seen as a direct threat to the king's life because for the Assyrian Empire civilization, they see the normal bright moon as royalty to the king. Okay, this is associated with the royalty to the king. I mean, the normal bright moon. Okay, so now when the moon turns red, it is a problem for them. It is a problem. So they think it is a curse. They think it's a curse. So what they do is that before it happens, someone is replaced, is reached, okay, and kept on the throne of the king. So that's the typical king there. So somebody comes and replaces the king. Why the king goes into hiding? So when the lunar eclipse occurs, the curse, the, when the lunar eclipse occurs, the curse will be placed on that substitute on the throne. Okay, so that is the idea. So after the lunar eclipse, the king will come back and assume his throne. So that is how they avoided the curse on hitting the king. So that's how they explain it. So it's weird for the moon to turn red. So they explain it as a curse. How about the Chinese, the ancient Chinese? Okay, so they believed a celestial dragon or a demon was believed to attack the moon just as it did to the sun. Remember when we talk about solar eclipse? In the daytime, the sun suddenly becomes dark, it goes away. So it seems like something is swallowing it. Just forget about your modern science. Just imagine you were in the shoes of these Asian people. Okay? All of a sudden, the sun disappears. Becomes dark. So they think that there was an attack on the sun. Okay, they never knew it was the moon that was blocking. Okay, so they thought there was an attack on the sun. So in the same way, the lunar eclipse during when the moon becomes red, they assume that the moon is also under attack. That is why it is looking red. So what they do is that they start beating drums, they start shouting, they start shooting arrows into the sky, you know. So and all this they create noise to drive the predator, the demon, away, and to restore the moon's bright color, to restore the moon's light. So that is how they perceive lunar eclipse. It makes a lot of sense to them. How about the Native American traditions? For the Native American traditions, they viewed a lunar eclipse as a sign that the moon is very sick. Oh, the moon is very sick, and the one it is the moon is wounded. Something strange wounded the moon, or the moon is in distress. So what they do is that communities respond with prayers, with rituals, and other ceremonial activities. So they believe that these practices were intended to restore the moon's health and brightness. Okay, How about the medieval European folktale? In the in the European in the medieval European folktale, lunar eclipses were often regarded as signs, signs or warnings. Okay, so some people in Europe associated in lunar eclipses with plagues, famine, wars, and other disasters. So the lunar eclipse could also be interpreted by other people as a sign of a ruler's illness or death. So these beliefs reinforce the moon's association with fate, change, and the cycle of life. How about Africa? Africa tradition. Okay. In the African tradition, lunar eclipses were interpreted in different ways across African societies. It's not just one common agreement because African is diverse. Okay. So in some traditions, an eclipse could be seen as a sign of conflict, danger, or an important change affecting the community. Some other communities responded with prayers, singing, drumming, or other communal ceremonies. In certain traditions, the eclipse was understood as a temporal struggle between celestial forces, with people symbolically helping to restore the moon. So these traditions demonstrate how celestial events were often connected to community well being, spiritual beliefs, and the natural order. How about the Jews and Christian beliefs in the Bible? If you read the Bible, you will see a lot of emphasis of the moon. Okay, okay. So lunar phenomena, not just lunar eclipse. Okay, even solar eclipse. Okay, lunar phenomena were sometimes interpreted through the language of science, prophecy, and divine judgment, particularly in passages describing the moon becoming like blood. There are so many passages ranging from the Old Testament to the New Testament. Okay, so they view these things as a sign. Okay, all right. So, how about modern astrology? Modern astrologers often interpret lunar eclipses as period of change, transformation, and emotional intensity. So, to them, a lunar eclipse is sometimes associated with endings, revelations, or turning points in a person's life. Some astrologers also believe that eclipses can bring hidden issues to the surface or encourage personal growth. So, however, in our modern era, our scientific understanding has improved, and now astronomers have realized that lunar eclipses result from the predictable motions of the Earth and the Moon rather than supernatural forces. Now, I don't want to be misunderstood. Okay, I do not want to be misunderstood. I'm not trying to use science to explain all these ideas away. No, these are traditional beliefs, and it stays with some people no matter how advanced they are in science. So I'm not trying to explain them away. I'm not trying to attack your tradition, but I just highlighted the beliefs. It's not I can't call it misconceptions. I just call it beliefs, traditions of people that you know, that ascribe their beliefs to these heavenly phenomena. So I hope I am not misunderstood. So let us discuss lunar eclipses and their role in advancing science. Okay, starting from Aristotle, he used lunar eclipses to prove that the Earth is spherical. Because back in those days, a lot of people believe, a lot of civilization believed the Earth was flat. Okay, so Aristotle argued that Earth is not flat, that Earth is spherical. So he used lunar eclipse to prove it. So during the lunar eclipse, you see that the shadow of Earth is shifting, it is being cast on the moon, and it appears to be spherical. So showing that Earth is spherical. It's only a spherical object that can cast this kind of shadow. So, so if the Earth was flat, it would have cast this kind of shadow, and we have not seen this kind of shadow during any kind of eclipse. So it debunks that idea that Earth is flat and Earth is round. So Aristotle used the lunar eclipse to prove that Earth is spherical. And how about Kepler? Kepler's work on lunar eclipses and orbital paths. Johannes Kepler used lunar eclipse data, several data gathered over the years, to study the shape of Earth's orbit and refine his law of planetary motion. Observation of the moon's motion during eclipses helped him confirm that planetary orbits are elliptical and not perfectly circular. An Indian astronomer used eclipses to refine his predictions. Okay, he used both eclipses in 500 Common Era, um, before Common Era. Okay, his name is Aryabhata. He's a pioneering Indian mathematician and astronomer. He developed sophisticated methods for predicting lunar eclipses. His work demonstrated that eclipses were not supernatural events, but predictable astronomical phenomena, laying the groundwork for later advances in celestial mechanics. Like I said, he used both eclipses, he used lunar eclipses and solar eclipses to refine his prediction. And it works, okay? It kind of worked that time. So let us talk about the science of this lunar eclipse, the geometry of the lunar eclipse. To understand lunar eclipses, you need to understand lunar phases, okay? Because as the moon orbits Earth, different portion of its surface, its sunlit surface, becomes visible to us, okay? So the major phases are the new moon. So let me move forward. Make this, I want it to start from the new moon. So this is, this is the, this is the new moon. So during the new moon, you don't see this, you don't see the moon. You don't get to see the moon during the new moon, okay? But as it continues to orbit, begin to see the first quarter. Call it the waxing crescent. Sorry, I made a mistake. Waxing crescent, begin to see it. This is our view from Earth. Begin to see it. Okay. Then that is so from there we enter into the first quarter. So the first quarter, and from there enter the waxing gibbous, and we now enter the full moon. So that is what we see as the full moon. Then it continues to waning gibbous, then to the third quarter. So this is third quarter now. This is quarter. Then we have the waning crescent, and it goes back to its new moon phase. So this happens every month. Oh, this happens every month. Okay, it happens every month, and the question is, if it takes 1 month for the moon to go around Earth, and we see these phases, why are we not experiencing lunar eclipse? I told you lunar eclipse happens when you have the sun at the center. Sorry, you have the Earth at the center. So why are we not seeing it here? Why? Why are we not seeing it here? So that's the question. So so to answer that question, it lies in the tilt of the moon's orbital plane. You know, the tilt between the Earth and the moon. So this is how they are tilted. If you look at this picture, you know, we are looking at this from the top. So so when the moon orbits Earth, you don't get to see they are tilted. Okay, it's like you're looking at Earth from a satellite. You don't even know which one is high and low hills. Okay, so but if you look at it from sideways, you see that they are tilted. Okay, so because of that tilt, the tilt is about approximately 5.1 degrees. Because of that tilt, see that the shadow of the moon is always missing Earth, and also the shadow of Earth is always so. I could have drawn a shadow here. So the shadow is you know protruding like that. So it's the shadow of the Earth is missing the moon, while the shadow of the moon is missing Earth. Okay, so that is why we don't get to see. Uh, that is why we don't get to see it every month. Okay, so that is why we have full moons, but we don't get to see lunar eclipses. But something remarkable happens during eclipse seasons. Okay, so here is a picture of Earth going around the sun while the moon is also orbiting Earth. Now, two times in a year, two times this happens 2 times in a year, the orbital plane of the moon around Earth coincides with the orbital plane of Earth around the sun. So that's a cross. Okay, that's a cross there. And that point where they meet is called the nodes. So if the moon happens to be in that node, I told you it happens 2 times a year. One time it could cause a solar eclipse, another time it can cause lunar eclipse. So, but the moon has to be in that node. That node is where they are almost straight, like they are straight. There's no like those tilt like this, so like almost straight. So the Earth's shadow cast on the moon, okay, and we witness lunar eclipse. So let us talk about types of lunar eclipses. Number one is total lunar eclipse. In a total lunar eclipse, the entire moon passes into Earth's umbra, passes into Earth's umbra, and no direct sunlight hits the moon, and the moon glows red. So you can see there. Okay. Then we have the partial lunar eclipse. Here, only part of the moon enters the umbra, and a section of the moon appears beaten or darkened. So look at that. It's looking darkened, the other one looking normal. Okay, so that is the one we're expecting this week or next week's 27, 28. Then we have the penumbra. I don't know, okay, so the moon passes through Earth's penumbra. So, and that causes a subtle dimming of the lunar surface. And that is, and we don't get to notice it. We don't get to notice that unless you use a very powerful telescope to, focus on it and you can see that. But if you look at it, it just looks like normal. Looks pretty normal. So here is a diagram of all the types of the lunar eclipse I've just shown you. So here is the sun, here is Earth. Okay, so as the sun, as the sunlight travels, okay, hits here. So people here will see the day. Right here, people here will see the night. Okay, just experience the night. Okay, so now the if you do the diagram, the red diagram, and here is the shadow of Earth. So this is the umbra part. This is the umbra, the darker part. Remember when I talked about umbra in my last lecture? Here's the penumbra. So this emanates from the red diagram. Okay. So here is the moon. Here is the moon, regular moon that is outside the Earth shadow, like normal other full moons. Okay, it misses it. It goes above and below the shadow, so you can see that's full moon. So this is the penumbra. So this is the lesser shadow of Earth on. So this is where you experience penumbra lunar eclipse. The one I just explained here. So then here is the total when the moon is engulfed in the Earth shadow, and here is the partial lunar eclipse. So you see, so one part of it is in the penumbra, and one part of it is in the umbra, and this is the one we are expecting very soon. This is the one we are expecting. And notice that the moon is engulfed in the cone of Earth. It is engulfed, totally engulfed. Or like when we did solar eclipses, the tape was touching. It was the tape, like this tape here, that was touching Earth. So that's why we saw a patch of the Earth darkened. Okay, but here the entire moon surface look red. Okay, the entire, so it's not just a patch of it, the entire, because it is engulfed in the the Earth's shadow. So this is overview of 27 to 28 August. We're going to experience partial lunar eclipse. So here are the regions of the Earth. America is going to experience it. Almost all the America, almost all Brazil. Africa is going to experience it. However, it's going to happen in the midnight for the Americans. It's going to happen during sunset for the Americans, but for Africa and the rest of it, it's going to happen during midnight. Most people will be asleep by then. But if you wake up at midnight and you come out with a telescope, you should be able to see that. So here is a simulation of how it's going to be. So here is the partial. Watch that. Watch that. So it is not going to cover the entire surface. It's going to just cover about 90 something percent, 90 something, not 100%. So that is the simulation. So now the question, the most important part is, why does the moon turn red? Why does the moon turn red? Very important. One of the most fascinating features of total lunar eclipse is that the moon does not simply disappear. It was supposed to disappear because during solar eclipse we see this dark, right? We see this dark spot. We don't see red. Do we see red? No, we see dark. We see the lunar shadow, dark. Okay, so so the moon does not disappear when it enters Earth's shadow. Instead, it often becomes red, orange, copper color, or even a dark brown. So this is sometimes called the blood moon. It looks blood. It looks like, that kind of thing is weird. It's weird even to some people in this modern time, despite the science, despite the awareness. It is weird. So why not dark? Why not the moon disappear? Because because if it were the other way around, assuming Earth, I don't know how to say it. Assuming moon was big, or remember what I just told you here. It is it is engulfed. It is engulfed. So if it's engulfed, I was supposed to disappear, right? But it turns red. Why not dark? Why not just disappear? So we're going to come back to why that is that is so. So let me take you to physics. Physics 101 about light and prism. Okay. So here is a prism. We use it to study light refraction. So here is light. So now the speed of light in a vacuum is constant. It does not change. So that is why it is white. Well, remember, light is made up of different colors, like you can see here. How we see this color is when they enter a denser medium. When it enters a denser medium, like this, okay? Now, when it enters a denser medium, the medium affects the components of the light spectrum differently. For instance, blue light is affected more than all the way to the lesser frequency ones, to red. So red light is affected less. You understand? So take it. Blue light is affected more. It is slowed more. It is slowed more. So that is why it refracts at a higher angle. So if you extrapolate this distance, you see the it refracts. It refracts more. It changes direction. The angle changes more compared to other colors. So it changes as you go up to the less frequency spectrum. So when it comes out, it's divergent, though, is another angle, even bigger ones. So what I want to point out here is we call this dispersion. Okay, dispersion. Okay, it's split. It is called, it's caused by refraction. Dispersion is caused by refraction. Okay, so we also notice that during rainy season, okay, the rain droplets in the atmosphere split it into different colors. That's a overall combination. You see these colors. Okay, these beautiful colors. Okay, so that is by the way. So I've talked about refraction. I'll come back to that and or dispersion. I just call it dispersion. Now look at the sky. If you go outside in the daytime, you will notice that the sky is blue and the clouds are white. So why is that so? And the reason why it is so is that um, this is another process. Okay, not this other one I showed you now. So we call this Rayleigh scattering, and it's caused by tiny dust particles. Now have shown you that light contains all of these colors, right? Blue and I told you that blue light is mostly affected when they enter a different medium. Okay, so that in combination with the dust, there are dust in the atmosphere, that fine dust particles, micron in size, almost the size of the wavelength of this light. So when light from the sun hits our atmosphere, they interact with these dust particles. And because I've told you the blue light is affected more, it is dispersed. It is dispersed. It is scattered. It is scattered. Why other light colors penetrate? So why is the cloud white? The cloud is white because the particles, the water droplets that make up the cloud, are bigger in size compared to the wavelength of light. So when that incident on on the cloud, on those water droplets, they recombine and they still produce white. Okay, they still produce white. So that's exactly so why the sky is blue and why the clouds are white. Now let me apply that here. In the daytime, the sky is blue. Okay, when you look up, you see the sky that is blue. Okay, that what I've just explained. But that is midday. But during sunrise and sunset, have you noticed that if you look at the horizon, the sun will be red in color, and you can safely look at the sun. Okay, why is it possible? The reason is because the distance it takes those rays of light to travel from the sun to the atmosphere, like it travels a longer distance. So it has encountered lots of these particles, these dust particles, fine particles in the atmosphere. Okay, so they scatter the blue light, they scatter all the heavier light, and what is left is the red spectrum. So that is why is the atmosphere is red. Now, when you look at the sun appears yellow. Or if you look at the moon, they appear yellow. And some people misunderstand it as blood moon. No. If you go out of this earth, if you look at the moon, they look white. If you look at the sun, they look white. So this is just an atmospheric effect, okay? Because of the distance it travels, the light travels, it scatters it. Now applying that to these. Let us explain why the red. I guess you should understand why the red is now happening because of the far distance. It travels farther from here to here is far greater than from here to here. So it travels through layers and layers of the atmosphere that that scatter helps to scatter it. So we now have the red remaining, and that is why we have that red emanating. So when the white light from the sun comes here, it grazes through the atmosphere here. So it encounters the atmosphere and also the dust particles. Okay. Now, the atmosphere without the dust particles refracts the light. Remember what I told you about this prism? It changes the direction. So it acts as a like a cone. How do I explain it? Like a lens. Good, like a lens acts like a lens. So it bends those light, it bends them. It bends them, okay? So the atmosphere, so without the dust, separates them because of refraction, because the light moves at different the light spectrum move at different speed. In addition to that, the atmosphere also helps us scatter it more. The dust of the atmosphere helps us scatter it more. So we have this red coming out from here. So when the moon enters that cone of red from the cone of shadow for the moon, we see it red and it is intrinsic. So even if we go out of space and look at the moon, it looks red. So this is not the same as sunset and sunrise. So don't confuse the two. So this is not the same. So this is exactly what happens. We see the blood moon. We appreciate it. So have you seen the science now? This is the science. I'm teaching you the science now. So, but why are we not seeing the same for lunar eclipse? Why is it not appearing? Where is it? Why is it not appearing dark? I mean red. It's appearing dark. It's appearing dark. Why? It's because the moon has no atmosphere. So no atmosphere to refract the light, no atmosphere to scatter the light. So we see dark. However, there are some studies that say that the moon has a minute atmosphere, and I've seen some pictures of solar eclipses having red outings, like the outings are red. I've seen some pictures on the internet. I don't know how true those pictures are, but on average, the moon has no atmosphere. So if the if the Earth had no atmosphere, just imagine if the Earth had no atmosphere. It means that during lunar eclipses, the moon is going to disappear. So it is going to disappear because of Earth. It's going to be engulfed in the Earth's darkness, Earth shadow. You're not going to see it. Okay, so that is exactly what happens. So let us talk about how to observe lunar eclipses. Okay, it is generally safe to look at the moon during lunar eclipse. There's no danger. You can look at it with your eyes. Okay, look at it. But if you want to have a better experience, you need a binoculars, you need a telescope, so you can zoom in closer to the moon to take beautiful pictures. All of these pictures that I've shown you about eclipses, we're taking with telescopes. It's how close it was zoomed. Okay, so but if you look at it with your eyes, you will not even notice the color. You may not even if you don't have a good sight. A lot of people don't have good sight. You may not even notice like this. It is. You might think it is weather problem. No, it's red. Or if you want to just use your phone, you can even use your phone to just photograph it. So that is the end of my lecture. So thank you very much for listening, and you can add your questions in the comment section. I'll respond to them.